campus. So now I would like to ask Trilok sir to begin this event.
Thank you, Nishtha. Um, Good morning, everyone. So I think that we have already all of with meeting with all of you in some of the courses. Definitely, we have met either in mathematics one or in mathematics two. So no need to introduce to myself. I think that most of you know about me. So this workshop, which I have got the idea about this workshop, is that students are facing a problem in working with MATLAB environment, and they want someone to say that okay, so let's start, and I am here to help you. And if you have any doubt, then I'll be there to sort it out. Otherwise, I think that it is just a software which or all other softwares are there, even more than that. But and the problem is only that whenever it's just like a swimming exercise, you can say, whenever when we are outside the swimming pool and we'll see that so lot of water is there, so we are always afraid of it, that whether we'll jump into it or not. But when we are inside the pool, then we'll feel that it's as easy as anything, but we have to practice for it. And because mathematics always required practice, so before we'll start this workshop, I just want to make two you can say claims. One claim is this, that uh, this MATLAB, I am quite a lot time, means I am doing this MATLAB earlier, but now I think for around 3-4 years I'm not working with MATLAB, because most of my scholars are doing now the job for me on MATLAB. So my practice is little bit less now on MATLAB. And number two, that I'm not a good programmer. So the workshop is that it is a MATLAB programming workshop. But I think that the audience, or in the audience, I have better programmers than me, because my practice on the programming is also not so good right now. But and I'm not discussing much about the programming aspects. Will basic programming tools, or basic programming, you can say, syntax will discuss. Otherwise, we'll not discuss much in this programming also. So as the information I have got from the organizers, that people want the from the beginning of the MATLAB, or from, you can say, we'll start from the zero. So with this in mind, I have prepared these slides, that I am teaching the students, those who are at the beginning level. But I think that you all are aware of mathematical background. So not much mathematics is to be teach. Only the MATLAB part I want to teach, not the mathematical part. Okay, so with this basic, you can say, assumptions, I am starting this workshop. So MATLAB is what? Uh, mm, if we can say, so introduction. This is my idea, that I am giving you the introduction of the MATLAB. But programming part, I think that you are better programmer than me. Because if most of you have done the course in the computer programming, so you are better programmers, because I am totally out of it. So what is MATLAB? So MATLAB is a high-level language and interactive environment for numerical computations, visualization, and programming. And now some more things have been introduced by MATLAB, because MATLAB is also having the Simulink also. So there you can simulate, or simulators are also there, where you can simulate your programs, or you can see the things when you can say really happening in front of your eyes with the help of Simulink. So MATLAB and Simulink both are there. So it's not only a programming language or computational, you can say, software. It now MATLAB is, you can say, offering lot of things to the, you can say, their clients. So MATLAB, what you can do in the beginning, we can say, you can analyze the data, you can develop the algorithms and create some models and applications for your study point of view, we can say. Because but you can do lot of things with MATLAB, not only the analysis of data and developing algorithms. Now many more things have been introduced, you can say, attached with this MATLAB. So once you have get acquainted, you can see that there are a lot of scope of doing work within the MATLAB environment itself. So the language, the tools, and the built-in math functions enables you to explore multiple approaches. So One is language, another is the say there are inbuilt tools and inbuilt mathematical functions. So you have lot of support from the MathWorks, which is the organization which has created this software. So MathWorks providing lot of support also, and not only the you can say anything which is inbuilt in your system. They are also providing you the live support also. They have their website. There are they if you can put their problems there, they will give you the solution. They will try to solve it for you also for their clients. So it's depend upon that what is the you can say level which type of client you are, whether you are the professional, whether you are researcher, whether you have the personal license, whether you have a multiple license. So all these things are will play a role, but definitely the system is dynamic. The things are changing day by day, or you can say on a daily basis. So there are a lot of things which MathWork is providing to us. So it is developed by MathWork in 1984, and the full form is Matrix Laboratory, but in short form, as Bitsians are very good at it, so we can say the full form is the MATLAB, but it's not the name which is Bitsian has given. This name is popular. So this Matrix Laboratory is the initial name, but now it is popularized as MATLAB. And it is developed by this MathWorks, which is one company which who has developed this software. So how MATLAB is working? So MATLAB, the
Excuse
first
me, sir.
point. Yes, sir.
So can you please show the previous slide?
Yes.
Thank you, sir.
Okay. No need to note all these things. This is just when the things are there to note, I will definitely tell you. I hope that every one of you, those who are present in this workshop, they have because this information is also been shared that you all have your MATLAB software installed in your system. So when we'll discuss the things that you have to do it on your system, then we'll also ask about it. But what is the first thing is to understand that because it is in MATLAB, everything is a matrix. So that's why the name is their Matrix Laboratory. So whatever you can say MATLAB is working, they are understanding everything in the form of an array. So the basic data element, or you can say, for example, for us, anything which is basic is the numbers. But numbers are, you can say, in matrix or in MATLAB, any real number or any number can be considered as a 1x1 matrix. So generally in mathematics, everything is either considered as a, you can say, set, but in MATLAB, everything is considered as a matrix. So whatever we are giving as an input or defining anything in MATLAB, it is MATLAB as a system understanding it as a array or a matrix, whatever you are giving in the MATLAB. If you are giving a string, then it is a, or you can say string of vectors or a sequence of the vectors, then it will become the vector. And vectors are also matrix, whether it is a column vector or a row vector. Or if it is a two-dimensional, then it is a two-dimensional matrix. If you have multiple dimensional data, then also MATLAB understanding it as any, you can say matrix in the n dimensions also. So it's not only that in only row column, you can have vertically upward data also. So that is also been understood by the MATLAB, but all things in the MATLAB are considered as the in the form of array. So MATLAB features a family of application-specific solutions called toolboxes. So MATLAB, whenever you are installing MATLAB, and if you're installed by yourself, then you can see that you have to select the toolboxes on which you want to work. So there are toolboxes which has been developed by MATLAB to support the, you can say, functioning of the MATLAB. So these toolboxes are the application-specific solutions. So today I will try to reach at least cover one of the toolbox for you. And I have decided to discuss the symbolic toolbox, because after the basic mathematics, the next level of mathematics is that you are doing the mathematics with the variables. So how to work with the variables in MATLAB, that is, if you understand, and then I think that most of your problems for using the MATLAB has been solved by using the symbolic toolbox. Because as an engineer, whenever you are facing an equation, because anything when you are converting into a mathematical form, you will end up with an equation. It is mostly a generally differential equation. So if you are being able to reach at that level, that at least basic differential equation I will be able to teach you. So that is what my aim for this particular session. That but depending upon the pace of the lecture, that how much we can cover in this 1-2 hour workshop, because it requires a lot of practice also, so that you can understand the concepts. So I will try to cover one of the toolbox, which I am covering as symbolic, but there are other, for example, for optimization specific problems, there are optimization toolbox where you can use the calculation related to the simplex table and LPPs, transportations, assignment problems. So for different type of problems, there are inbuilt functions which you can use with these toolboxes. So optimization toolbox is there. Statistical toolbox is there, where you all have all the inbuilt functions like what is the mean, mode, mean and median, or you can say what is the standard deviation in normal distribution, how you can assign the probability PDF, CDF. All these things are there in statistical toolbox. So these commands are stored in this particular type of toolbox, and there are the uses of this toolbox with the particular applications. For statistics, you have further now specific toolboxes, but we are not discussing these software which are performing statistical calculations far better than the MATLAB, but MATLAB also supporting some of the statistical applications. Now the MATLAB has two type of licenses. One is professional version, and second is the student version. But most of the institutes, or in BITS Pilani, we have the student version. So student version of MATLAB provide almost all the features of the professional, you can say, MATLAB, with no limitations and the full functionality. But because professional versions are basically the problem specific, that if you have a particular type of problem, you want to attack on a particular type of problem, and you want a particular type of application of the MATLAB in that is there, then we can or you can say we can also purchase that type of license for our particular type of problem, because in research we are facing the problems where we are not been able to solve a particular problem with the already you can say available toolboxes. One question is there, that which toolboxes we should have. So basic in the student version, you have almost all the toolboxes, and it depends upon your necessity, that which toolbox you are on, which type of problems you are working. So basic toolboxes are there, which is MATLAB is basically there. But I have, for example, right now discussing the symbolic toolbox. So symbolic is also a basic toolbox which you can always have with this MATLAB version. And you can also that is again depending upon your problem, whether you are working with you can say figures, then you have to have the graphical toolboxes. If you are working with some, you can say, electronics problems or electrical problem, then you have to choose the toolboxes according to your choice. So there is no any suggestion on that which toolbox you should have. It is depending upon your problems. Now we will using in this version in this workshop as the student version. So what are the resources? Because I am available for the first time here for 2 hours here, then I am also busy. And as I have already tell you that I have very limited knowledge in MATLAB also. So if you need any support or any resources from the MathWorks, you can say, so there are some website which are MathWorks website. So on these websites, you will have lot of support and lot of literature, videos, you can say demonstrations are also available on these websites. And I am also learning through these websites only that what for a particular type of problem, because generally the problem in MATLAB is that we are doing the wrong, using the command with the wrong syntax sometimes. So for that, you required some support from, you can say, MATLAB resources. So there you have MATLAB resources. Some you can say you will be able to access what you can do. Do we need to separately install any toolboxes? That again, the same question is there. My answer is that which toolbox you need is you can say it's not known to me. It is your problem that which toolbox you required. Mostly, you can say with the student version, you will have almost all types of toolboxes, but there are toolboxes which are problem specific. For example, I am working in fractional calculus, and I am right now working in fractional neural networks. And there is a toolbox in MATLAB which is fractional applications of fractional order neural networks in some problems. So that is known as FOCON or FONN. Now it is another name is FONN. So that toolbox is not available with the student version also. For that toolbox, I have to pay, and then it will be Mathwork will give us the license of using that particular toolbox. So but that is a very specific problem, specific toolbox, that if you are working in fractional order neural network, for example, if you are working in image processing, so if you want to work in the image processing, then you should purchase some of the basic toolboxes which are freely available. But some of the toolboxes which are for the image processings are also there, which are problem specific, or you can say which demands a lot of things to do in the programming itself. So then you have to purchase it also. Or you can order your problem. Generally, for example, I have a particular type of problem. I can contact Mathwork also, and they can construct a toolbox for my specific problem also. But then for that, you have to pay. Otherwise, for the student version, for learning point of view, the toolboxes are already freely available. So these you are not required to purchase. But if you are working on a particular problem at a research level in a laboratory or in some commercial point of view, for your bank, for example, you are working in bank, and in bank you have to perform some particular calculations in a particular manner, then you require a particular software for it, then you can ask a particular software and you can purchase that type of toolboxes for you. So it is depending upon your problems. So through which website you will be, through these websites, which is our support websites, you can get the information about the Mathworks products, new products, how they are used, their demos, MATLAB based books and documents. All the literature is available there, videos also available there now. Technical support in the form of M file. Sometimes something is not been clear, or something is there, or some new things have been you can say added, which we have not purchased when we are purchased the MATLAB. Then you can add on these things. Some things are it is again depending upon the company, that some of the M files are freely available, some of the M files you have to purchase. So MATLAB systems contains the following parts. One is development environment, one is the MATLAB mathematical function library, MATLAB language, which has some syntax and commands. To handle the graphics, so there is a separate portion of how to handle the or how to construct the graphs in MATLAB. So this is one of the tool in MATLAB, how to handle the graphical tool, you can say. The MATLAB application program interface. Sometimes what happen, you have written a program in some other language and you want to call that program in MATLAB system, then you require this API application program interface. Or sometimes you have written a program in MATLAB, but you have to run that program in some other environment, then also this interface is required. So these are the MATLAB systems. So development environment, where you will write your programs or your, you can say, functions. Function library, where you already have inbuilt functions, for example, sine theta, cos theta, sin x, cos x, log x, the values of these functions, you can easily have the functional library. The language means there are some MATLAB command which you want to use, some graphical commands or graphics, how to handle graphics, and these MATLAB API. So I am discussing the development environment. So it is a set of tools and facilities that help you to use MATLAB functions and files, MATLAB editor, command window, command history, the workspace, the current directory, array editor, help, toolbars, and shortcuts. So all these things you can find out in the development environment. So I am now showing you when you open the MATLAB, then what you will see in MATLAB. So when you open the MATLAB, so then you will have this screen in front of you. So here you will have some toolbars. You have some toolbars. This is showing you on the slide. First I will show you, then I will show you on the real situation also. So pointer, laser pointer. So here you can see that these are the toolbars. You can say file, edit, debug, and then you have some basic tools here, which has been shown in this screenshot. The help button is there, or help separately, help is there. Then command window, here you will write your commands and you can run your program in this space. You can write your commands and run your programs. Current directory is the directory where you will store your M files or all the files which are related with the MATLAB. Workspace is the place where you will store your view, you can say program variables. Double click on any variables and you can see in the array editor that where that variable is used. Here you will have command history also. So in this environment, you can adjust according to your preference also, that you can take this to up and low down, that what's also there. But all these things are somewhere settled in this screen. So I will show you that how your screen look like when you will open the MATLAB. So I think that everybody has opened the MATLAB. That when you click this, okay, I will just close it and then I will open, then it will be better. So I'm closing it here. So I'm showing you the MATLAB on my, so here you can see I have a MATLAB link, and when I will click on this, so this will be shown. I think everybody is clicking it now. You can see that. So initially you have all the details related to license and all this. The version you are using, we are using R2021B, which is available in BITS Pilani. Just wait, it will take a little bit time. So now this window has opened. I think that 2 times I have clicked, so that's why. So here you can see you have one command window, current folder or library here, workspace. You can see here, you can see the name of the, right now it is blank. Nothing is stored here. You can have command history and all these things also. When you will run some command, then you will also find out the command history, and command history can also be, you can say, accessible when you are using the arrow keys. So upward arrow keys or right arrow keys will give you the commands which you have earlier used. So that was the, you can say, environment of the MATLAB. So anything you want to work is this place here. If I will again, because pointer is now not working, you can see my, I'm scrolling at this point where fx is written. So whatever bin you are working or whatever command you want to type at this particular environment. Some, because in some other versions you can see the this window which which is opened here in a different look is there, because I have also seen some other looks of the MATLAB. So I will just show you another look where of the MATLAB in some other versions of the MATLAB. So here you can see that command window is there. Here you can see we have the array editor, you can say editor of the program editor is there. Command history is right now is here. Array editor is here. Here you have your libraries. Here you have toolbars and shortcuts. One place is there for workspace to store the variables. Another point is the help point. So you can see that in some of the, you can say, version, you can see some different setup also. So that is depending upon the versions of the MATLAB. But once you are been, you can say, familiar with the MATLAB, in one, you can say, particular screen, you can easily understand that what is there in a particular screen in the some newer or some other versions. Now we will move on to the next slides. So now there are different types of file we will create in MATLAB. So for functions and scripts or to write programs, we will use M files. For storing the figures or for graphics per point of view, we are using fig files. And for data storage and for data inputs and data outputs, we are using the mat files. So important thing is the help button on the top of MATLAB window, you will be getting what? So the most important thing which now I am teaching, telling you is this button, that this button is here, help button. You can see on your screen that this help with the question mark is there. So when you press this button, you can see that you have certain commands here, documentation, examples, support websites, license, help related to the licensing, check for updates, accessibility, terms of use, patents, about MATLAB. So you can see that anything, any information you want to get for the MATLAB, you can get through this help button. Generally, I am using this help button mostly for examples, that if I have made any error, for example, I am using the command here with this syntax. Suppose I want to sum two numbers, and suppose I'm using anything here, 5:10. Suppose I have written this. You can see what happened. So here I have got this, the sum from 5 to 10. 5 plus 6 plus 7 plus 8 plus 9 plus 10. But suppose that instead of this colon, now I am using, here you can see that I have all the command history. Whatever command I have typed earlier, you can see they are here. So if I will write here, instead of this, I will use comma instead of colon. So what happen, you can see. So then I also have a syntax for it. But suppose that instead of sum, I will type summed. And you can see that MATLAB is showing an error message. So suppose that I do not know what is the command for this summed summation of the numbers. So I will go where? I will go in the help button. I will check here. I will go the examples. And then I will check that in the example, I will search that what is the command or syntax for the summation of numbers. Just want to know how to do the summation in MATLAB. Just enter it. Now symbolic summation is there, numerical summation is there, sim sum is there, integral image is there. You can say that all the things which are related with the command summation, you can find out. And not only in the, you can say there are 34 results related to the summation command in MATLAB, you can see. So for all the point of view, you can find out that how to get the summations, you can say command related. For example, symbolic summation, if I will talk. So the command is sim sum or the sum. So then you can say that they have all the comparing, that how you can sim sum, what is the meaning of this command, how to use this command. There are some examples also given. For example, this sum of these 10 terms of this series. So you can use this command by using the, you can say example is also given here. So use this command and you can learn the things about it. And this is the only way of, which is the, you can say, most convenient way by which you can learn MATLAB without help of anybody else. Okay, so whenever nobody is there to help you, the God is there. So for God in MATLAB, this help command is our God here. Okay, so anything, if it is not clear through help command, then only you required someone expert in the MATLAB to help you, that whether it, how it can be done. Otherwise, most of your doubts can be solved through this help command. You can look for the videos and other literatures also available in the Mathur website. So this is the main feature we can say here in MATLAB to resolve all type of queries or all type of problems. Okay, so if now in the future, if you have any doubt, first check the help command, then go for anybody else. Okay, so here you can find whatever is there. I have already mentioned in the showing you the help command, and now you can see that this is different look of this is the 2013 version. You can see the version of the MATLAB here. I'm just showing you. So you can see the MATLAB version here. Can you see the version? This is the older version. So this is the look of MATLAB in the older version. Something you can say the workspace is here. For your point of for your version, the workspace is here at this place. Here you have workspace in your version. But in the 2013 version, the workspace is here. So only thing is that the shifting of some of the windows from here to here, or some you can say look wise, this is a different look of the 2013 version. So these are the things which are different here. But these command is same is here, and these type of help you will find out in the MATLAB when you are using the help button there. Now the important commands which are always been used, and I think that these are important commands in all programming languages. So CLC means it will clear, it is just like a duster on the blackboard. So if you have to want to write the something on the blackboard, what you want to do, first you have to rub whatever is written earlier using the duster. So this CLC command is nothing but the duster in the MATLAB board. Then clear command is clears all the previously defined variables. It means it will clears the workspace. Then clear XY means that it will clear a particular variable, not all other variables. For example, you want to save some variables which you have already defined, then and you want to only clear the variable X and Y, then you can use this clear X and Y. Disp command is display the value of any stored in any variable A. Whose command, sometimes we want to know that what is the nature of the variable, whether it is a syntax, whether it is a you can say string, whether it is a 2 by 2 array matrix variable, whether it is 1 cross 1 variable. So that if you want to know, then it will display the all the you can say details related to the variable A. List all the known variables. So if I will give the command who command, then whatever variables we have defined earlier, all the variables have been listed by the help of who command. Help, I have already mentioned. Help on a particular topic, then you can just type help, and then this syntax is here. Here you can write whatever topic you want to. Then, for example, help sqrt means help on using the command sqrt. How to use the command sqrt, then you can use this syntax. So these are some important commands which we are frequently using in MATLAB. Now, some important things to remember. Orange line is there if we are writing any M script or any file in programming in MATLAB. So if you encountered with the orange line, then it means that it is indicating some warning, some mistake has been done. Red line means that there is definitely an error. Save projects always before running your program. This is always been taught in any programming course, you already know. And if you are using the run button, so I will show you where is the run button also. So you can see here if I will, so for example, I have already inbuilt some commands, so I will use this demo. I will open this demo. So you can see that this editor is there. This is editor file. So editor is here, and I have written a program which is already been saved here in demo1.m. Now you can see whenever you have this programming file which is there and you have write any program, after that you will have this green button with arrow which is called run button. So if you press this run button, then MATLAB automatically save this program and run for you. But if suppose that I do not want to run and I will close this editor window without saving it, because now it is already been saved, so it will not going. But if I will close this window without saving it, then what happen? Whatever I have written in this editor file, it will delete it. So I will not get anything which I have written earlier. So please always save your program whenever you are creating any program. So before you can say running, generally you can save your program and then you will run. And if you are using the run button, then it will automatically saving your program and running for you. Similarly, for a big and large programs, always use the breakpoints. This is you can say programming tool, or you can say programming tips, you can say. Now, mathematical operations, basic operations, arithmetic operations, logical operators, and less than equal to, greater than equal to, strictly less than, strictly greater than, mathematical functions, maximum, minimum, sine, cosine, graphical functions, plot command is there, text command is there, input output operators for reading writing from the or to the files. So you can also you can say make the programs which are user you can say interactive, that you can ask something from user, he will input some value, and then the program will perform something for you. So that input output operators are also there. In MATLAB, whenever you can just type this 4 by 5 4/5, and if you are using this right slash, then it is 1.25, means it is 5 by 4. So this is to remember that if you are using in MATLAB, if you are using left slash 4 divided by 5, and if you are using the right slash, then it is 5 divided by 4. Now in MATLAB programs, no need to define variables or objects beforehand, as you are doing this in C language, that to use any variable, first you have to define that variable before writing the program. So that is not, if for example this command you are already aware of what is int a, what is double, what is float. These are the types of the variables. So no need to define the variable or of the objects beforehand the program. Whenever you will require that variable or objects, it is MATLAB automatically define that variable. So when you can say, see, for example, as I am writing example x equal to 5. So MATLAB automatically assign the value 5 to a variable x. So automatically define the variable x in itself. I am writing x1 is equal to 2. So MATLAB automatically assign a value to this variable xn. So this variable is being created by MATLAB itself only whenever. So it's not required to define or to initialize any variable in the MATLAB. So after these statements, a variables are 1x1 matrix with double precision. So you can just try these commands. These are very basic. A is equal to 15. So you will get B is equal to 28 by 5. So you can see that output of this command is not written in the form 28/5. It is the result of this calculation. So what is 28 by 5 is been written here in the form of B. Now, if you'll give the command whose, then you can see all the variable list here, A, B, these are the two variables, and you can see the all details that what is the size of the variable, how many bytes it is using, what type of it is, whether it is a string or a double command, double variable, so that you can see. If you'll perform the multiplication A star B, then you can easily get the multiplication of 15 with 5.6, which is 84. Okay. Anything which is, I think I have got some chat box messages are there. Can anyone tells her to turn on recording? Is it done by me? Because I have not created this link.
So we are the organizers of the meet. However, due to the student Google Suite which we use, we aren't able to record the meet. We don't have the permission to record the meet. So
you do not have permission from Google, but from my side there is no problem. If you want to record it, you can record it.
Okay, thank you, sir.
Okay, but I am not been able to record it because you have created this link. So I am not been able to start the record button here.
Yes, sir. Yes, we know that.
Okay, so shall I move now? I think that all other things we have already discussed. So list of arithmetic operators. So operator assignment, you can say to assign any value, we are using the symbol A, equality. For unary operators, so for negation, we can say minus of the variable, it will give the negative value, whatever is stored in the variable A. Addition, subtraction, these all things you can easily understand. Just I am showing you on the slide that these things you can perform with it. Yeah, we'll be sharing the slides after the session. There is no problem. So these are the operators: multiplication, division, power, transpose, or you can say you are using these symbols. So for multiplication, A star B. For division, I have already mentioned. For power, you have this cap. For transpose of a matrix, you have this command colon. For the giving the you can say range from 1:4. 1, 2, 3, 4. You can write it as 1:4. Now, MATLAB variable names are very important because variable names are case sensitive in MATLAB. So variable name can contain up to 63 characters as of MATLAB 6.5 and newer. And variable names must start with the letter followed by the letters, digits, and underscores. So first name of any variable should always be a letter. You cannot define a variable name 1-3 or 1-5, 1-A. A1 you can define, but 1A is not a variable in matrix in MATLAB. So this you have to always keep in mind. Another thing is that it is case sensitive. So if you are using a small case or you can say uppercase, so both variables are different. For example, if I am writing a small case, you can say AB, or lowercase AB, then both variables are different. So whenever MATLAB come across a new variable name, it automatically creates that variable. I have already explained you this earlier. So the rule is that can be a mix of letters, digit and underscore, but first letter should always be a means first you can say entry should always be a be a letter. So vector underscore a or vector underscore a1, but not vector dash a. This is not possible. Underscore is possible, but dash is not possible. No space should be there in the name of the variables. Different mix of capital and small letters you can use. You can see that a underscore capital V, capital A, capital V, small a, R, I, A, small b, capital L, E. This is one variable. But a underscore V, R, I, A, B, L, E for all small cases is a different variable. For all variable, you can say letters are capital, then it is a different variable. So all these names are different variable name in MATLAB. So we can define characters also in MATLAB when and where they are required. So for example, character variables, I can define CHAR AAA. So answer is equal to AAA. If I will assign this A is equal to answer and disp A, then I can see that it is AAA. And then if I will use the command who's A, then you will get this command. So I am just giving a pause of half minute. You can try these commands by your own with your on your screen and check whether you are getting these answers or not. So it will only meaning that we are getting the character strings, and you can see that we can CHAR is the command by use which you can define the strings or characters in the MATLAB program whenever you required to define these characters. So use this disp command, use this whose command, and you can see that the syntax is different for this command and whose command. If I'm just showing you that again, if you are using whose A, for example, if I'm saying CHAR AAA, this is what I have given you. Now I am saying capital A is equal to answer. Answer is also a variable right now. So this is there. Now if I will give the command whose and I'm using this bracket, then what happened you can see. It is not showing anything. But if I'm using whose command with this syntax A, then it will show me the all the properties which is there. If I'm using disp command, disp capital A, and you can say that it is only displaying this string A. It is not considering it as a variable. But if I am showing disp capital in the bracket, then it is using this capital A as a variable. And you can see the answer is AAA. So the syntax is very important in MATLAB, that if you are not using the correct syntax or correct from the command, then you are in trouble. But you know that how to come out with this trouble by taking the help from the help button. That will be the best help which is available on hand whenever you are using the MATLAB. String command is also used. Sometimes we can use only this as you can say string command. This you can say apostrophes are there, so that you can use for the string command. So you can say string. This is a string. So this you can see variable name is a string here, and it is stored as the string command. And now I have written this string, so it is showing me the result which is there in the string command. So now list of relational operators. So MATLAB supports 6 relational operator. Again, less than, less than equal to, greater than equal to, and not equal to. So these are the symbols for these commands. You can see that this equal to commands has 2 symbols. One is that when you are comparing something with the equality, then you are using this equal to command by using 2 times this equal to symbol. But when you are assigning something to a variable, then you are only using 1 time. So when you are using equal to in a logical statement, then you will always use this symbol. When you are assigning a particular value to a variable, then you can use only single times equality. So here you can see that what are the outputs of these commands. So here you can see I have used A equal to 15. So here I have only used 1 because I am assigning the value 15 to the variable A. B equal to 12. So assigning the value B is equal to 12. But if I am giving the command here by after getting this that A double equal to B, then the answer which I have got is the 0. For example, here I have written A less than B. So answer 0 means that my command, the comparison is false, or you can say it's failed here, and A is not less than B, by A is greater than B. Similarly, when I am writing C less than B, the answer is 1. It means that my logical output of this statement is that my answer is 1, means that this is correct. So you can say for correct it is 1, for false it is 0, for true it is 1, and for you can say false it is 0. And similarly, if I will assign, you can just use the command clear, so that all the previous variables, you can see that now workspace is become vacant. There is no nothing is there. So if I am using A is equal to 15, enter, B is equal to 10, enter, and now if I am writing A double equal to B, the output is logical 0. Answer is logical 0, means that this is false. And if I am saying A greater than B, the answer is again logical 1. So it is illogical, you can say symbols less than, greater than, less than, equal to, greater than, equal to, and not equal to. So when you are using this command, you will get the logical output for this. Now, predefined variables and symbols. So these are some symbols and you can say variables which are predefined. So please avoid these names whenever you are defining a variable. Please do not use these predefined variables and symbols, because then MATLAB will be you can say stuck that whether you are you want to because it is already been defined. For example, please do not define any variable with the name as ANS, because answer for MATLAB is already a default variable name for the final result. Pi, this is the value of pi. Similarly, INF, please do not give these names as your variable name. NaN, which is not a number, for example, 0 by 0 is not a number. I and J, generally they are considered as the iota or square root of -1. So please do not define any variable with these names. Similarly, 3 dots, continue statement on the next line, comma, which is separate statements and data, percentage, because it will means that in any program, if you are using percentage, you already know that it will not execute that command after whatever been written after percentage. It means that it is only a comment there which you have kept for your understanding. Similarly, colon, specify the range. So please do not use these predefined symbols or variables as your newly defined variables. So what are the common errors which we are doing? So types of errors in MATLAB programs is syntax error, which is the most common error. So check spellings and punctuations. Sometimes runtime errors. So sometimes what happen, you are not checking the data. For example, I want to get the summation of first n natural numbers, and I have asked the value of n from the user. And suppose user has put n is equal to iota. Then what happened, my runtime error has been occurred, because now the loop which I have created for getting the sum of first and natural number, and because the input is not a natural number and I have not put any check on the inputs, so therefore what happened, the program will not been able to execute, and we have been stuck at some point. So these are some runtime errors. We can check the input data. Similarly, logical errors that check typos or check units, and sometimes check the syntax I have already mentioned, but proper syntax is also sometimes very important, that which syntax we are using. So now we will move on to the matrix case, that how to you can say matrix operation we can perform in MATLAB. So we'll do it little bit quickly. So these are some basic matrix operations which we are going to discuss one by one. So what we mean by the matrix? So matrix is the collection of data or values, generally of the similar kind, but they can be of the different kinds also, but they are generally of the similar kind, organized into rows and columns and known by a single name. So for example, if I am having a capital A, then we have some rows and columns in that capital A, where I have put the similar type of objects. So M by N, or you can say Aij, M rows and N columns as J changes. Matrix can also be considered as vectors and arrays. So size of an array is specified the number of rows and the number of columns with the number of rows mentioned first. So for example, n cross m means that it has n rows and m columns. And the scalars are also treated as an arrays by the MATLAB. So for MATLAB, a scalar is also a matrix which is of 1 cross 1. So 1 cross 1 matrix is a scalar for the MATLAB. So 1 row and 1 column. Now generating, how to generate or how to get a matrix in MATLAB. So how to generate a matrix. So there are two ways of generation of the matrix. It can be generated with the, you can say, user defined matrix, or it has already inbuilt matrix functions are there. You can use these inbuilt functions to get some of the matrix very quickly. So some most commonly used approaches are user defined and using predefined operators. Using predefined functions also, some random generation is also possible to get a matrix. So first thing is that a matrix can be created in MATLAB by following command. So this is the first command you can try. So I am defining a matrix. Just type it on your so what is the output there? You can see, because every time it is not possible for me to go on the actual MATLAB. So I have put some screenshots here. I think that that will be helpful, but you can try by your own whether you are getting the same results or not. Just try this and see that you will get this output. This is the actual picture of MATLAB, you can say command window. This is what I have typed, what is I have got as an output. So you can see that I have got an matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 by just, you can see the difference here. At after 3, I have written semicolon, but between 1, 2, 3, I have written only commas, but here I have written semicolon. So semicolon is there because of it is a, you can say, separator for the rows, while comma is the column separator. So you can see that some other ways also. For example, if I want to define a vector of length, in which all the entries are 1, 2, 3, 4, 5, 6 up to 10. So I am getting a row vector. So 1 colon is just to specify the range. So 1 colon 10 means that it is a vector starting from 1 ending at 10. Now you can see the another application of this colon, but this time I have used 1 colon 3 colon 12. So this time I have to write the numbers between 1 and 12, but 3 is specifying the distance between two numbers. So it is 1, then after the increment of 3 I have got 4, increment of 3 I have got 7, increment of 3 I have got 10. So it is 1 to 10. But it is not necessary that this 3 will divide this 12. Sometimes you can also get 1 colon 3 colon 12, the semicolon, and then you will get 2 colon 3 colon 13. And again, you can see that I have to stop at 11 because the next number is 14, which is not out of my range. So in that case, my answer is this. And you can see that this semicolon is there. So therefore, I have got 2 rows. In row 1, I have got these numbers. In row 2, I have got these numbers. So this is also a matrix. And you can see that MATLAB automatically assign the answer to this matrix. So this matrix, right now the answer is a variable, and this variable has the values for this matrix. If I will define B like this, then you can get this matrix. Again, you can see that it is a 4 by, because how many rows are there? 3 rows. So it is a 3 by 4 matrix and 4 columns. I hope that my pace is okay and you are getting the same answers while trying these commands. I have already given the first command as clear. Why clear command? Because in our lecture, we have already used this capital A or capital B. So if suppose that you have used capital A earlier for some other assignment, then again, reassigning the values sometimes create problems. So it's better to always use the clear command and CLC command so that you will get a clean board and clean workspace. I hope that now you have done this on your computer system and you have understand the use of this colon and semicolon and commas. So now you can see This colon specify the range. This semicolon space, this is a row separator, and comma is the column separator. So this is the actual picture of the command window. You can again see that I have also used the space instead of comma for the column separation. So I can write 1 space, 2 space, 3 space, 4 space, 5 space, 6, 7. Then I will again get the same matrix. Now the y, you can say that 1, 2, 3 semicolon, 4, 5, 6 semicolon, 7, 8, 9. But again, this time I'm not using commas. I can use space also. For null matrix, I can use this symbol, empty brackets. So this will specify the null matrix. Similarly, 7, 8, 9 like this, you can get the and you can say matrix from in the MATLAB. Then you can use the already you can say specified functions, or by using some matrix generation functions. So I am giving you some of the example, not all the examples, because it is not possible to cover all the examples in this session. So, but you will get an idea that how to get the some inbuilt functions for getting the matrix generation. Sometimes what happen that instead of typing all the entries in the matrix, we just want to test something on a matrix. For example, I want to test only the transpose command. So I want any matrix can work for me. So for that purpose, I want a quick matrix to type. So in that case, these commands will helpful for me. So one command is the zero function. So it will give me all the entries as zeros in the if the size of the matrix has been specified. So command is b is these are the syntax. So b is equal to zeros bracket n. It will give me the n cross n matrix whose all entries are zeros. M comma n, you can easily understand it is written an array whose with m rows and n columns. If I will define m, n, p and so on, then I have already explained you that we will get multi-dimensional matrices also. Similarly, zeros of size a. So suppose a has already been defined a matrix, and now if I will say zeros of size a, then I will get a matrix whose all entries are zero with the size of the matrix a. So that is also a inbuilt function. And with the help of this, you can quickly get the matrix whose entries are zeros. So you can just try these commands. And one of the command you can just try and you can see that you will get it or not. But this is one way of getting the matrix quickly of the size zeros. So this is the command window I have used here. So you can see that syntax is very important, and this red command means there is a error. And what is the error I have done? I have typed the zeros with capital Z. So zeros, if I have the syntax is a small z as z is there, so I have to use the correct syntax for the command. I have used here another command called magic 3. So I am explaining you what means by the magic 3 in coming slides. Magic will return us the magic matrix. So similarly, I have got a command for once. That once, same thing is there. Only difference is instead of zeros, you will get ones. Only difference is this. All syntax and all meaning is the same. So you can see the output. Once 2 means I have got 2 cross 2 matrix with all entries as 1, 1, 3, 2. Once 3, 2 means I have got all the entries as 1, 1, 1. Pascal A is equal to this. Once size A, answer is this. I function will give me the identity function. So, but in case of identity matrix, I will not get the matrix of multiple sizes. Only identity matrix is only available for the dimensional. You can say that m cross n is only possible, not m cross n cross p cross r. That is not possible in case of identity function. So this is the only limitation there. So I3 will give me the identity matrix with 3 by 3 matrix of all entries 1. Diagonal entries are 1. Similarly, I2, 3 will give me a matrix of rows 2 and 3 columns, but main diagonal of the matrix is having the entries as 1. All other entries are 0. So you can see I2 comma 3 will return us 2 rows, 3 columns, but the main diagonal is 1, other entries are 0. If A is magic 2 comma 2, so this is an error with the magic command, that magic 2 comma 2 is not possible. But we have a command with Pascal 2 comma 2 by which you will get the entries of the matrix as the entries from the Pascal triangle. I'm not going in detail about but I'm just showing these commands here that you can also try these commands to get quickly the matrix. Because यदि आप इस command को try करते by using the user defined matrix, so what happened that you have to put all the entries there. Magic command, I will tell you what is the magic matrix. I will just tell you right now. This is the magic function. So it is a function. Magic n will give us the n by n matrix who's constructed from the integers from 1 to n square. The order n must be a scalar greater than or equal to 3. So for magic command, n should be greater than or equal to 3. So for magic, we do not have the magic of 2 or 1, but magic of 3 and more than that is there. And what is the magic here? You will get a square in which all the entries, if you add them with row wise, column wise, diagonal wise, all entries are ending up with the 15. So sum of all rows, sum of all columns, sum of all diagonals are 15. So that's what that is why it is called the magic matrix. But it is a quick way of getting a matrix. This is why this command is useful. That if you want to just try something on a 3 by 3 matrix, so just to want to get a quick matrix, you can just give the command magic 3. So that will give you a 3 by 3 matrix in which you have all these 9 entries. So, but we do not have magic 3 comma 2, but magic 4 is there that you can easily use. Similarly, you have rand function. So rand will give you the random numbers as the entries of the matrix of order n. And the same thing, all these commands is there. One command is there, rand I. It will give us the integers from uniform distribution from 1 to n. So rand n will give us any number, but rand I will give you the integers. So it will separate. For example, your entries must be any integer, then you should use rand I command of order n. But if you are using randn command, then your entries can be fractional numbers also, or it can be any real number is possible in case of randn, and they are the randomly generated numbers. So random numbers are I think that you all are aware of random numbers, that how to generate the random numbers in probability statistics. I think that you have been studied about the random numbers. I'm not going to teach you here that what we mean by the random numbers. Just go the probability statistics notes that what we mean by the random numbers there. So how to generate random numbers of different sizes, that will be the entries of these matrix from random commands. So suppose you do not want 1, 2, 3, 4, 5, 6, you want some decimals places numbers in your entries to test it, then you can use this command also. But if you want 1, 2, 3, but in a random manner, not magic matrix, then you can use this command also, rand I command. Then the empty matrix, I have already explained you. But if any of the row or any of the column of the matrix you have specified as 0, for example, in the command I command, or in the, you can say command zeros command, or in the command 1 command, suppose I have put one of the column or row as 0, then what happen? I will end up with a null matrix or empty matrix, because then the size, if it is 0 by 5 or 10 by 0, the answer is null matrix. So for example, you can see zeros 0 comma 5. It means that what happened? 0 rows and 5 columns, but it will return me a empty matrix. So you can just try these commands to get the how to define empty matrix. Now I have a break of 2-3 minutes. I just want to have a glass of water and then I am coming back. Just try these commands. I'm just coming back in 2-3 minutes. Any doubt till now? Anything which has not been clear? Shall we move further? Have you tried these commands? So now these are some basic operations, addition of matrices. So when you have, I'm just showing you the examples and the main problem there, because time is little bit short and I want to cover at least some of the, you can say one of the toolbox, that is symbolic toolbox. So here you can see 1, 2, 3, 4, 5, 6. It is a 2 rows and 3 columns, and n is 4, 5, 6, 3, 2, 1. So again, it is a 2 by 3 matrix. So you can add them by simply adding the variables by taking the plus. So m plus n, and here the size of m and size of n is same. So you can do m plus n and m minus n. You will get some results there. But the problem is that if the size of the matrices are different, then you will end up with an error message. So if my A is magic 3 and B is Pascal 2 is also a command to get the matrix, where the entries of the matrix are entries from the Pascal triangle. I hope that you know about the Pascal triangle. So these are, you can say in that manner. If I am not here, it's very difficult for me to show you. This is 1, then 1, comma 1, then add these two here, and you will get 1 here and 1 here. Then here again we have got 1, 1 plus 2 is 3, 2 plus 1 is 3. So you will get all the binomial coefficients like this. And then if we'll make the metric entries like this. So this is 1, these are 1, 1. Then you will get 2 here. Then you will get 1, 1, 1 like this. So all entries of this Pascal triangles, if you are getting them in a matrix form, then that matrix is the Pascal matrix. But here it is the order of Pascal matrix is 2. Order of magic matrix cannot be 2. So you can see that if we'll add these two matrices, the answer is a error message because the size of the matrix is not matching. So if whenever you are adding two matrices, you have to be the size to be the same. Similarly, but you can add a scalar to a matrix in the MATLAB, that if I'm writing 3 plus 8 means that what happened, I am adding all the numbers of A by the number 3. So I am adding a 3 in all the entries of this matrix. So I am ending up with the 3 plus A. So then I have got a matrix P, which is 3 plus A. So adding a scalar is possible by using this plus symbol, but adding two matrices with the different size is not possible in case of MATLAB. Now the multiplication, you already know the rule that when you can multiply two matrices, that you can easily do. So and how to do the rule of the multiplication is this, that any entry you can get k is equal to 1 to p aik bkj. That is a basic linear algebra formula, that how to get the multiplication of two matrices. So you can see that you have a 3 cross 2 matrix, and then you have a 2 cross 3 matrix. If you multiply it, you will end up with a 3 cross 3 matrix. Again, if that will not match, then for example 3 and 2, then p star q is the matrix. Now we are using some other commands to generate quick matrices. For example, inf commands of size 3 means all the entries are infinity, and that is of a 3 cross 3 matrix, and the multiplication you will get all the entries as infinity. P into R. P is magic 3, R is all entries as inf, then P into R is possible. So I'm showing you some of the commands in examples, but I'm not discussing much syntax because they have the similar syntax as zeros and ones command. But you can try whether 2s or 3s commands are there or 4s command are there. These commands are not there, but zeros, ones, identity matrix, inf command, these are available. 3 star p, what will return us 3 star p? Multiplication of any matrix by a scalar. So you can see that all entries of the matrix have been multiplied by this 3. So then you have got 3 star p. So just try these commands quickly. Transpose, I think that you already know what the command meaning. So if we have null matrix, the transpose is also null matrix. If I will write is identity this one B is equal to 120 means what? B is a matrix of size 1 by 1. So this is what B is what MATLAB understanding. The MATLAB is taking it as it is a 120. So that transpose of this matrix is also 120. If I have got identity matrix of order 2, transpose of, I will again end up with the identity matrix of transpose 2. So in all the three cases, you can see the transpose is same. Similarly, diagonal will give me the diagonal and main diagonal entries. So if I will take the magic 5 and I will take the diagonal, this is the main diagonal. So I will get the main diagonal is 7, 5, 13, 21, 9. So this is the diagonal of it. It may possible that in your case, if you type some magic command 2-3 times, then you will end up with a different matrix also. It is also possible that sometimes for a particular order, you have 2-3 magic matrix. So again, diagonal of the null matrix is null. For 1 cross 1 matrix is the same. And so these are, if you are using diagonal command, then you can see that for these matrices, you will get for null matrix, diagonal entries are 0. There is no diagonal entry, so it is null. For 1 cross 1 matrix, diagonal entries are only that entry is there, 1 cross 1 matrix. Now, concatenation is an important you can say tool in case of matrices, because it is a process of joining small matrices to make bigger ones. So suppose the pair of square brackets is the concatenation operator. So for an example, I will start with a 4 by 4 matrix square A and form this matrix. So you can see A is a magic square, means A is magic 4. And now I have defined B as keeping this A into this square matrix. This is square. So now what happened? I have concatenated this B, and the entries of B's are entries of A, entries of A plus 2, then entries of A plus 48, and entries of A plus 16. You know that this is the row separator. So you can see here that if I will type this command, B is equal to A plus 32, this is space here, and A plus, then I have written in the next line A plus 48 and A plus 16. You can also use the command which is I have given you in the previous slide. And you can see that I have now got a 4 cross, from a 4 cross 4 matrix, I have got a 8 cross 8 matrix. So by helping of concatenation command, I can get the bigger matrix from a smaller matrix. Similarly, you can use, so these are the different position of matrices. Similarly, you can delete or row a column to get a shorter matrix from a bigger one. So you can delete and rows and columns to use just a pair of square bracket. You can done by using the colon operator and an empty matrix. So for example, if you want to delete the ith row of a matrix A, or the ith column of a matrix A, then this you can use. So if I want to row ith row, then I can put that colon in the place of ith row, and I will put an empty matrix here. So this command will help me to get the remove of the ith row from the matrix. And similarly, ith column from this matrix. And similarly, this command will help me to remove the ith row. So this is ith row, and this is for ith column. So again, I have used Pascal 5. Now you can see that if I will say you can say colon, comma 2 is equals to this. So what happened? This second column have been removed. And in case of A, 4 comma 2, it means that the fourth row, this row has been removed. Sorry, not fourth means यहाँ से जाएगा ये 1, 10, 20, 35. Yes, any doubt?
Yes, sir.
Yeah.
So when we run this command, to matlab, does it remove the row only to display, or does it actually remove it from the A variable?
It is always all removed from the variable A, and it will assign the if you will assign the A variable to this, you can again assign some other value to the variable A. Then you can also write this is equal to another variable, but it is actually removing this particular row or column from the matrix A.
Okay, sir.
So automatic assignment is happening, is it, to A?
Yes, A is now becoming a smaller matrix after doing this.
Right, sir. Thank you.
Now deletion of a row and column. So if you delete a single element, is it possible to delete a single matrix, a single element from a matrix? Single row or column we can delete, but an element we cannot delete. So the expression like that we are want to, and you can say delete a 1, 2 entry from the matrix A2 as a null matrix, that will result in error. So we cannot remove a single element from a matrix. It should be either a complete row or a complete column. That you can do. Now the inverse and determinant, for that you have command. The syntax is y is equals to inverse of x. It means that it will give me the inverse of a square matrix if it exists. So Pascal 3 as my command, inverse will give me the answer as this. This is the inverse of this answer. So answer is the, you can say this matrix, because this matrix is associated with now answer. And now if I will put inverse of answer, then I will get again answer, and my answer is now updated like this. And now if you again give the command inverse of answer, you will get back this matrix, because you know that the inverse of the inverse is again the original matrix. But the difference you can see that if you take the inverse of the answer again here, then you will get these numbers, but with the decimal 000, because after calculation you will get, and now these numbers will be converted into the decimal up to decimal 4 places number. So 1.0000 you will get instead of 111. Now the determinant. So command is determinant of x. Again, we want to use a square matrix of the matrix x. In other matrix, if you are using, you will get an error message. So for example, again, Pascal 3, if I am giving the command a is equals to this, x is equal to determinant of a. So the value of x is coming out to be the value of the determinant of a. So these are some commands you can practice. Now some manipulation you can do in the matrix. So few specific functions are defined in MATLAB to perform various manipulation of matrices and arrays. So they are listed and described hereafter, but I am not describing all the manipulation command. For example, and command, what we are expecting, it will give me the last index of the array is empty. It will give me a logical command that whether the matrix is empty or not empty. So if I will try is empty command on a matrix, if it is an empty matrix, then the answer is 1. If it is not an empty matrix, then answer is 0. So these commands are generally helpful us to put a check in our programming. For example, we have asked the user to enter a non-empty matrix, but the user has put some empty matrix there, and we want to give an error message to the user. So in that case, you can use this command, whether it is empty or is infinite or is finite, is nan, is numeric, is real, is scalar. All these commands are there for the programming point of view. So to check whether the entries which has been asked from the user is correctly the same thing or not, which we have asked. If you want to check for any variable, that is also possible, because in that case you can check whether the because your entry which has been taken by the user, given by the user, is also a for example, you want to take as a scalar that enter a real number. So when user put a real number in the matrix, in the MATLAB, what happened? MATLAB will take it as a 1 cross 1 matrix. Now you can check whether it is finite, is in for scalar also. So length will give us the length command. Max will give me the largest element in the array, min smallest element in the array. So all these commands are there, and now I am discussing some of the syntax, not all the syntax. For example, AND command. So just try A is equal to magic 5 and A bracket AND. So what I will get? I will get the last entry of this magic 5 matrix. Just try it. Now similarly is empty. So syntax is TF is any variable, is empty A. So description is return a logical 1 if A is an empty array, or logical 0 false otherwise, because if it is not an empty array. So empty array has at least one of the dimension of size zeros. We have already discussed 0 by 0 or 0 by 5. So it is just a command. You can just try A is equal to 1, 0, 5. So you know that number of rows are 0. So this is an empty matrix. B is equal to zeros of 1, 5. So 1 row and 5 columns means it is a row vector. So you can see what the output is: empty A and is empty B. Just try. In case of is empty A, you will get answer as 1. And in case of is empty B, you will get the answer as zeros. Is it clear? Is empty. Similarly, you can use other commands for checking. Is real, is inf, is nan, that you can easily check. Is finite. So same thing is there. Only difference is that it is a finite or infinite number. For a complex number z, is finite, return 1 if both the real and imaginary part of z are finite, and 0 if either the real or the imaginary part of is infinite or nan. So just try it, is finite command, and also try for B -2 inf 0 nan 1, 2. So just try both the commands. In one, you will get answer 1, and in the case of B, you will get answer as 0. But here you can see that is finite is not giving you only the 0. You can see here 2 minus 1, 0, 1, 2. You will always get 1, 1, 1, because in case of matrices, you will get the logical one that it will checking all the entries. So 1, 1, 1, 1, 1, it is checking all the entries of the matrix. Is finite, it is checking all the entries which numbers are finite, then it is giving as 1. That if the number is infinite, then it is giving as number 0. Now the application of MATLAB and linear algebra. So these are some matrix manipulation you can do. Now I am discussing the, not only these are the some manipulation, I have already listed many of them. And other than these listed manipulation, you can do other manipulations also. But for that, again, you have to check the syntax and the commands with the help of help button. Now I will discuss how to solve a system of linear equations by the command RREF. So obtaining eigenvalues and eigenvectors of a matrix, how you can do the LU factorization, and how you can get the roots of a polynomial. So this is one application of MATLAB in linear algebra. So solving a system of linear equation. So first thing is how to take the matrix as an input a system of linear equation. Suppose I have this system of linear equation and I want the solution of this system of linear equation. So first problem is that how to enter this system into matrix, but into MATLAB. But the solution is, because it is a system of linear equation, so you can have a equivalent system of matrices. So what is the equivalent system of matrices? Is AX equal to B, where A is your coefficient matrix and X is your variable matrix, and B is your matrix, column matrix, and you will get AX is equal to B. So you have to just enter matrix A and matrix B, and we can easily enter matrix A and matrix B in MATLAB system. So just enter these matrices A and B. So enter this matrix by this. This is a user defined matrix. So 2 space 1 space 3 space 0 semicolon 3 2 0 1 semicolon 2 0 12 minus 5, and B is 16 16 5 with the help of semicolon. So now you can get C is equals to A comma B. So this is augmentation or concatenation. Augmented matrix you will get with the help of concatenation, A comma B. And now you can use the command RREF of C. So we are taking the augment RREF of C. You will get this matrix after getting the RREF of C. Have you done this? Now after RREF of C, you can easily see what is the solution. So from here, you can easily see what is the solution. X, Y, Z, T. So variable T is equal to 9. Which variable is the free variable here? That is also known to us, that because there is no pivot entry in this column. If you do not have any pivot entry in the column, then that column is your free variable. So this is column for X, this is for Y, this is for Z, and this is for T. So column Z is your free variable. Now variable T has value 9. Variable Z, sorry, variable Z can have any value. You can say K. So now X and Y can be defined with the help of Z only. So the solution is variable T has value 9. Variable Z has value K. Y you can use from here, that is minus 34 plus 9K, because this minus 9, if we go out other side, it will become plus 9K. And here we'll get 25 minus 6K. So that's how you will get the system of, you can say K is any real number. So that's the solution we have obtained for this system of linear equation. So if you have any system of linear equation, you can use the command RREF of that matrix, of the coefficient matrix. Now the eigenvectors, how to obtain eigenvalues and eigenvectors of a matrix. So for eigenmatrix, we have the command IJ, and if you want both the things together, then this is the more useful command, that V comma D is equal to EIG of A. So this will end up, V will give us the matrix containing the eigenvectors of A and as its columns, and D is the matrix that contains the eigenvalues of A on its diagonal. So that is, with the help of this, you can also have the eigenvalues diagonalization with the help of V comma D. So just try this command for the eigenvalues and eigenvectors of the matrix A. So D is the matrix which contains eigenvalues of A on its diagonal, and rest other entries are 0. And V is the matrix which is containing the eigenvectors of A as its columns. So this is another problem you can solve with the help of matrix, MATLAB related to the linear algebra. Similarly, you can use the LU decomposition of a matrix. So if you have a matrix A, then you can write this matrix A in the form of matrix L and U, where L is the lower triangular matrix and U is the upper triangular matrix, and the product of L into U is the matrix A. So this separation of matrix A into lower and upper triangular matrix is called LU decomposition of a matrix, and it is useful in many areas of linear algebra. So there you can get L as a lower triangular matrix and U as an upper triangular matrix, such that L star U is equal to A. So L is a matrix, U is a matrix, and the command is LU of A. But remember, A must be a square matrix. Similarly, you can get the roots of a polynomial. So important thing is that how to enter a polynomial in a matrix. in the MATLAB, because how you can use this x, how to enter this x. So here you are not been able to enter these x, but you can enter these numbers as a vector. So these 3 minus 4, 2, 17 minus 10, you can enter these as a vector to obtain the root of the polynomial. So the key is that MATLAB, a polynomial of degree n is nothing but a row vector of dimension n plus 1 cross 1. Because you know that in case of a degree 4 polynomial, how many coefficients are there? The coefficient for power 4, coefficient for power 3, coefficient for power 2, coefficient for power 1, and coefficient for power 0. So therefore, we have n plus 1 order row vector. So for this, we want to enter a row vector. So enter the vector 3 minus 4, 2, 17 minus 10 as an f. And then you can use the command roots of f. This will give you all the solution roots of f, because it is a 4-degree variable. So it will give us the 4 roots of the f in the form of the column vector. Just try it, that what are the 4 roots of this polynomial f. So these are some basic applications of MATLAB in the for the solutions of yes, we can get the complex roots also, Sukriti, Mathur. And complex entries are also an entry in the form of x plus iota y, where x is the real part and y is the imaginary part. Now we will discuss some of the programming points, because in the case of any toolbox you want to use, you must know how to create M files. So I'm just giving you how to create M file, MATLAB if, MATLAB for command. So these are the 2 things we will discuss here, how to use MATLAB if and MATLAB for. Just wait a second. So you can see here, if you want to create a M file, then here you have in your command window, I have done it on the side. Here you can see that here in this place, you will have some new file command there, some new file, already existing file you can open there, or you can create a new file from here. So you can use new script command there to construct a new, you can say, programming file, or you can, this will give you a MATLAB editor there. So I'm just giving a command clear so that all variables are clear, and CLC, so my screen is clear. So now if I'm using the new, you can say file is there. So you can say new script file. So when I will press new script file, I will get an editor named is untitled. So here I have got a space to write my program, and the number 1 is there. So first command always use CLC. Second command always use clear. Okay. So these 2 things you can always use. So these, you can say that now you can have the line number, and each line you can type a command there. And when you will execute this program, so it will start with line number 1 and so on. And you can write your program here. So that's how you can create your file. And when you will save it, you can save it in the current folder. For example, I have set a path for the current folder right now as program files, where I have stored the MATLAB files. And in MATLAB, I have constructed some of the demos file. And you can see the script of all these files is .m. So these are some already created files by me to demonstrate some examples. Okay. So I will show you these examples one by one once we will go. So this is the place where you will get new script file. Okay. And these are the places where you can go once, you can say path up and one path down if you want to move the from one folder to another folder. So that you can set here also. Then we will have, you can say here, script file, function file, new files. May new script means we want to write only script file. Functions, examples, all these things you can add. Simulink you can also add. But here we are right now discussing how to write a script file. You can also open already existing script file as I have already mentioned. When I will press this script file, I will get a editor here and I can save it also by the save button. So that is there. You can always have the save button here. This is the save button. So with the help of save button, you can save this file either in the current folder or in some other folder also. That is always possible. You know about it. Then this is my first program. We can write simple program in which we have given the command line by line. So clear, and after each command, you can always give a semicolon so that MATLAB will know that now he has to move to the next line. If I am not doing it, what happens when I will run the program? Every time I have to press the enter button to execute the different commands. So if I will not put semicolon here, what happens? MATLAB will clear all the variables, but then it will not go to this next line. For that, I have to press enter again. So it's better if you want to execute all the commands, you can say, and return back to the, you can say prompt, command prompt. You just always put this semicolon sign so that MATLAB will know that MATLAB want to move to the next line. So this CLC, then we have assigned some variables. A is equals to 24, B is equals to 43. Then we have performed some calculations. X is equals to A plus B. Now you can see that I do not require to initialize this X here. I have just given the values A and B, and now I have given the value X as A plus B, Y as A minus B, Z as A multiply B, and M as X divided by B. N is equals to A comma B, X comma Y, and P is equal to maximum of N, and Q is equals to this. So all these calculation have been performed, but you can see that once you have run this program, there are certain variables which have been generated, but you will not see anything on the screen. Because right now we have not given this command to MATLAB to show any value of the variable. Okay, MATLAB will do all this thing, and it will, if you run this program, you will, after running this program, just showing that what is there in this. Because I have made the program further, if I will run only up to this point, N is equals to this. So, but यहाँ पे ऐसा होगा नहीं क्योंकि यहाँ पे मैंने disp भी command एक use किया हुआ है. So after that, if I will stop here that N is this, P is this, Q is this. If I will stop at this point, then what happen? MATLAB will do all this performance calculation, and here in the workspace you will see all the variables, but you will not see these variables in your command windows because you have not displayed the values of the variables. So it is better that when you are performing some calculations, after that if you want to display it, use the display commands. So showing the output or externally, we will use the command display of the variable name, so that we will assign the value of the variable to this variable X, and it is showing on our command prompt. So it will show the value of the value stored in the variable X in M file on the command window. So if you want to display message in command window, use the command display. This is a message. So that is means this string is also been showed, and then you can assign a variable. So now if I will run this program on the MATLAB, these are some outputs. So I'm just showing you. So you can see that clear CLC command. These are assigning command, A plus B, A minus B, and these are just percentage symbol I have written just for the anything which is written here is only for the comment point of view, that Y is there. And now if I want to run this command, you can say demo one, I will just press the run button. So you can see that after running this command, here in the workspace, I have got some values A, B, M, N, P, Q, X, Y, and Z. And here in the command window, we can close this editor also, then we can see the command window. So these are the outputs of this program. The value of n is this. So now this message has been showing after the running of this program. The value of n is this. So you can see what is my n. N is this, and the value of n is defined here. The value of m is defined here, minus 3.5263, the value of q. And if you will give the command whose, you can see all the variables. M, N, P, Q, X, Y, Z, A, B. You can see the type or the size of the variable. Okay, so that is and the values which are assigned in these variables, you can also see in the workspace the value of a particular variable. So if you want to show the value on the command window, you can use the display command. If you do not want to, but you can see that we can only see the value of n, m, and q here. We are not been able to see the value of a, b, and p. We are not been able to see these values a, b, and p, but we can see the values from m, n, and p. Why? Because we only want to display these values. That's why these values have been shown after this demo one. So that's how you can create a m file and you can run your programs. Now if you want to take input from the user, so that is also possible. You can take the input from the user as x is equals to input, and please enter the value, and then that value will be stored in the variable x. So this will show the message, please enter the value in command window, and after getting input from the user, it will be stored in x that you can use in your program later at any point. So if you want to make a user friendly program, then you can also make in this MATLAB also. So I have already created a demo for this. So in the previous case, we have assigned the value of a and b by our own in demo 1. You can see in the demo 1 that a and b have been assigned by us. But suppose these a and b will be given by the user. So I am showing you demo 2. So a is input and b is input. And I have given a message with this variable also that enter the value of variable a is equal to, and enter the value of the variable b is equal to. So MATLAB will stop here and it will wait for the entry from the user. Okay, and then it will wait for the entry for the user from the variable b also, and then it will perform all these calculations. So remember that if you want to put a check over these values, then you have to use the command that is finite or is then. For example, here I want a natural number, but somebody will write the answer as pi or as some other non-natural number. Then my answer will not be executed and my program will be, you can say, stuck at that point. So for that, I want to check whether is finite, is real, is integer. These commands are useful at this point when you want to check whether the user has given the correct input or not, or correct type of the input or not. So if I will run this program here, so you can see in the command window that I have got the command enter the value of the variable a is equal to, I want to put the value 78. Now enter the value of the variable b. I want to put 5. Today is 5th February, so 5, 2. So 52. So now then I will go enter, and then you can see all these things will be executed. Value of n, value of m, and you can see the value of a, b, m, p, q, x, y, z all have been updated here. So you can execute n, m, the value of q, all have been executed here. So that this time I have taken the input from the user. So that this is the difference between demo 1 and demo 2. In demo 1, these values have been not been given by the user. It has been already inbuilt in the program. Then we can use the if command or for command. So execute statement if condition is true, and you already know the meaning of if and for command. I'm just explaining you the syntax that if expression So particular expression is true or false. If it is true, perform all the statements. If it is false, go to the AND command. So execute expression one, evaluate expression, and if the evaluation yield a logical one or true or a non-zero result, execute one or more MATLAB commands denoted here as the statements. Otherwise, go to the AND command. Now you can use multiple if also. So expression in MATLAB expression usually consisting of variables or smaller expressions joined by the relational operation. For example, count is less than limit, or logical functions example is real, like this. So simple expressions can be combined by logical operators and slash not equal to into compound expressions. MATLAB evaluate compound expressions for if from left to right adhering to operator precedence rule. Nested if statements must each be paired with a matching AND. So how you have to just count how many if you have put, that number of AND is also there to complement the if statement. So the if function can be used alone or with the else command also, or with else if function. So else if function means that you can go either or type when using else if and or else within if statement. The general form of the statement is if expression 1 statement 1, else if expression 2 statement 2, else statement 3, and then AND. I think that these things you already know, only syntax, and syntax is very simple in MATLAB. So just try display. This is a program for subtraction of two matrices. A is equals to input. So please enter first matrix. B is equal to input. Please enter the second matrix. Now, if you want to subtract two matrices, the important condition is that the size of A must equal to size of B. If size of A is equal to size of B, the logical answer is 1, then perform X is equal to A minus B and display the difference of the matrices. Else display error message and end the program. So we have just created this in our demo 4. So in the demo 3, sorry. So if we'll open the demo 3 file, so this is again clear and CLC command. This is a program for subtraction of two matrices. A is equals to input, please enter first matrix. Though this time you have to enter a user defined matrix here, and please enter the matrix B. If the size of A and size of B is same, X is equals to A minus B. Display the subtraction of two matrices is this, or display X. Otherwise, display the error message. So if I will run this, so please enter first matrix. So I am using the matrix 1 space 2 space 3 semicolon 1 space 0 space 4 and close and enter. Now please enter this. So I am entering another matrix of all, you can say zeros of the size. What is the row? 2, 3. So now you can see I have entered I want to use inbuilt matrix in the case of B, but it is not possible because it is user defined. So I have to enter the second matrix here. I cannot use directly the zeros 2, 3. So I can just enter the matrix here 0, 0, 0, and then 1, 1, and 1. So you can see after the subtraction of the two matrices, I have got A minus B as this. And if I will run it again, and if I will enter a matrix of the different size, for example, my matrix A is again 1, 2, 6, and matrix B is suppose 9. Then see what happened. I have got the error message that matrix dimensions must match. So that is the check you can put in the case of else if command. Okay, so this is how you can use if and else if commands. I think that we are not been able to cover the toolboxes because of the time constraint. Now we are reaching at the 12:50. So some of the things I have discussed with this or for command also. So you can see here, one thing is to be noticed is that if size of A double equal to, I have used here size of B, because here I have to check the logical equality. So that's why I want the output as a logical 1 or logical 0. So then I have to use this double equal. Otherwise, if I'm to assign something, then I will use only the equality sign. Okay. Now MATLAB for command, execute block of code specified number of times. So for x is equals to initial value and value, and initial value and step value and end value. Sometimes we can give the step value also. For that we can use the ranges. So for that we can use the colon command, and then statements and then end. Suppose that we do not want to take the increment by 1 only. If we want to take the increment by suppose 3, so 1 then 4 then 7 like this, then we can use this step value also. So description: for repeatedly executes one or more MATLAB statements in a loop. The loop counter variable x is initialized to initial value at the start of the first pass through the loop and automatically incremented by 1 each time through the loop. So the program makes repeated passes through the statements until either x has incremented to the value and value, or MATLAB encounters a break or return instruction. So thus forcing an immediately exit of the loop. So in the loop, when you are putting a break or return, then that is a immediate exit from the loop, where whether the condition have been met out or not, you will definitely go back to the out of the loop, in that case MATLAB program. So the scope of the for statement is always terminated with a matching end. So for end is also there. The values, initial value and end value, must be real numbers or arrays of real numbers, or can also be calls to functions that returns the same. So sometimes instead of initial value, you can use a value which has been a call from a function. Now for loop can be used to in the nested form, that is one for loop inside of scope of other. So that you can do, so that loop inside a loop can be used in combination of other loops also. So let's try this demo 4. So this is a program of summation of n natural numbers starting from 0. So n is equals to input. Please enter the value of n. X is initially 0. Now for I is equals to 1 to n, x is incremented as x plus I. And finally, when x will become the required number, then display the summation is display x. Okay. So when we'll get the value of n, we have already the value is from I is equal to 1 to n. So just see this program by the demo 4. So this is again clear CLC command, display n is equals to input. If n is greater than 0, x is equal to 0. For example, I have put a check here only that whether a negative integer is not entered. Suppose that somebody has entered -3, then what happens? This program will not run. So then I will initialize x is equal to 0. Then I have kept a for loop. I is equal to 1 to n, x is equals to x plus I, and display the summation is display x, else display enter n positive integer only. So if I will run this, you can see if I will, what happen if I will put a negative integer. So -7. So answer is enter n positive integer. But you can see if I will put a pi here, then the program, I am in a trouble there in that case. The answer is not correct. Then it will not running this program. Okay, because it is not giving me the correct answer. But if I will put running this program again, then what happen if I will put n is equal to 7, then the sum of the first 7 natural numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So the summation is 28. So why are now symbolic toolbox? I think that we can keep some other date for explaining you this one of the toolbox, so that you can perform or to solve at least the differential equations in mathematics. But now the time is almost up, and it is, I think that too much is stuffed today to you. So maybe you will first try all these things, and organizers, if they want, then I will again available for the at least to explain the symbolic toolbox. 1 hour I also required to explain the symbolic toolbox. So thanks for your patience. That's all from my side. If you have any doubt, then you can ask.
Thank you so much, sir, for your gracious presence and giving a very knowledgeable lecture. I hope the participants must have learned a lot from you. So thank you, sir, for your time.
Thank you. Any doubt, then still I'm here.
Students are requested to post their queries in the chat box. We might ask sir about your queries if you have any queries.
And please give your feedbacks also that whether you want from this level. Because from beginning, I am always taking, if somebody has says that we want from the beginning, then I will always start from this point. Because many of you, I think that are at some definitely some upper level, and if we'll discuss some toolboxes, then that will be useful. But because of the time constraint, it is not possible.
So could you discuss reinforcement learning toolbox?
Sir, we can say, we say that the toolboxes codes in the MATLAB are similar to that of Python. Yes, it is actually programming is the same thing. ना programming में तो कोई फर्क नहीं पड़ता, आप किसी भी लैंग्वेज में लिखिए, चाहे आप Python में प्रोग्राम लिखिए, चाहे आप C++ में लिखिए, programming language is same. A programming language can be different because syntax